Hi everyone, today we'll be talking about Fourier transform of 1 minus x square if mod x is less than or equal to 1, comma 0 if mod x is greater than 1. So from the definition we have Fourier transform of f of x such that x tends to xi, f of xi is equals to 1 by root 2 pi into integral over minus 1 to 1 minus x square into e power I xi x dx. For this we are writing the frame of Fourier transform. That is 1 by root 2 pi into integral over minus infinity to infinity f of x into e power I xi x dx. Though f of x value is 1 minus x square, we are not extending more than 1 because mod x greater than 1 is equals to 0. For mod x is less than or equal to 1, that is the x value lies between minus 1 to 1, then only the function value will be 1 minus x square. For other values it will become 0. So we are considering minus 1 to 1. So just to separate the terms, 1 by root 2 pi and integrate into integral over minus 1 to 1 e power I xi x dx minus 1 to 1 integral over minus 1 to 1 x square into e power I xi x dx. So integrating this we get e power I xi x divided by I xi under the limits minus 1 to 1 minus this we integrate by using Eilert rule. That is first function into integral of second function minus integral over derivative of first function into integral of second function. So here x square into e power I xi x, that is integral of e power I xi x is e power I xi x divided by I xi minus integral of minus 1 to 1 derivative of x square is 2x into integral of e power I xi x is e power I xi x divided by I xi into dx. So on substituting the limits here and here, let's see what we'll get. E power I xi minus e power minus I xi divided by I xi minus of e power I xi minus of e power minus I xi divided by I xi. So these and these terms will be getting cancelled. We will be remained with 1 by root 2 pi into 2 into x e power I xi x divided by I xi dx. So we'll integrate this term same by using Eilert rule. So now this term, so under root over 2 by pi 1 by I xi into x into e power I xi x divided by I xi, that is first function into integral of second function under the limits minus 1 to 1 minus integral over minus 1 to 1 derivative of first function into integral of second function, that is e power I xi x divided by I xi into dx. So substitute the values minus 1 and 1. So we'll get e power I xi plus e power minus I xi divided by I xi minus of e power I xi x divided by I square xi square and under the limits minus 1 and 1. So this under root over 2 by pi will be there and 1 by I xi do this. So 1 by I xi will be outside, e power I xi plus e power minus I xi divided by I xi plus e power I xi minus of e power minus I xi divided by xi square. On substituting the value of x, here we'll get this. So now as you can see, you will be able to relate this with 2 cos xi and this with 2i sin xi. So substituting the value and just taking out 2 outside. So on taking out 2 outside, will be remained with 2 root 2 divided by root pi into 1 by xi square minus cos xi plus 1 by xi sin xi. So just taking out 1 by xi square outside and we'll get xi cos xi minus sin xi and taking out minus outside. So on multiplying and dividing with root 2 we get minus 4 by 2 root pi into 1 by xi square into xi cos xi minus sin xi. Now by inversion formula we have f of x is equals to small f of x is equals to 1 by under root 2 pi into integral over minus infinity to infinity f of xi into e power minus I xi x d xi. So which is equals to 1 by 2 root pi into integral over minus infinity to infinity minus 4 by root 2 pi. We are just substituting the value of f of xi into xi cos xi minus sin xi divided by xi cube into e power minus I xi x d xi. Here we are just writing the frame of inverse Fourier transform. Okay. So after that f of x we know 1 minus x square which is equals to minus 2 by pi into integral over minus infinity to infinity cos xi minus sin xi divided by xi cube into e power minus I xi x d xi. So e power minus I xi x can be written as cos xi x minus I sin xi x. So now comparing the real and imaginary part. As you can see there is no imaginary part over here, but when you compare real part you have the real part. This real part will be equal to this part, that is this into this. So integral over minus infinity to infinity sin xi minus xi cos xi divided by xi cube into cos xi x d xi, which is equals to pi by 2 into f of x. That is, so since it is minus infinity to infinity, you can take integral over 0 to infinity 2 into integral over 0 to infinity sin xi minus xi cos xi divided by xi cube into cos xi x d xi, which is equals to pi by 2 into 1 minus x square. So now pi by 2 into 1 minus x square. So for xi is equals to x and for x is equals to 1 by 2 if mod x is less than or equal to 1. If we substitute the value, let's see what we get as is. So 2 into integral over 0 to infinity sin x minus x into cos x divided by x cube to cos x by 2 dx, which is equals to pi by 2 into 1 minus 1 by 2 whole square. That is 1 by 2 into pi by 2 into 3 by 4. That is minus integral over 0 to infinity x into cos x minus sin x divided by x cube into cos x by 2 dx, which is equals to 1 by 2 into pi by 2 into 3 by 4. So now on multiplying it, since taking out minus common from here, if we take out minus common we will get minus over here, but for convenience we will send this minus to that hand side, or we will just multiply with minus on both sides. So on multiplying with minus on both sides we will get integral over 0 to infinity x cos x minus sin x divided by x cube cos x by 2 dx, which is equals to minus 3 pi by 16. So this is how we can deduce the value for x is equals to x is equals to 1 by 2 and xi is equals to x. So thank you so much for watching. If any doubts, please do comment.